Welcome back. We're going to continue our discussion on colligative properties, and this time around we're looking at depression of freezing point. Again, why do we need to put salt, like regular table salt, on icy roads? Have you ever tried to lift an ice cube with a thread? Have you actually tried it? Why do both of these phenomena happen? Okay. I'm not still going to give you the answer. If you want, Google it or try to come up with an explanation based on the video about the content. All right, so just like we had an equation for boiling point, this equation is exactly the same for freezing point. Only difference is the subscript B, as in boy, is replaced with an F. And delta TF is actually the depression of freezing point. To actually find the freezing point, we have to subtract it from 0. And as with the previous case, I is the Van Hoff factor. For metal containing compound, you have to actually count the number of species. If your compound doesn't contain a metal, that means it's nonpolar covalent, like we learned in 170, so I is 1. Let's do a problem. So if 2.5 gram of calcium chloride is dissolved in 150 grams of water, what is the depression in freezing point? Kf is already given. An I value, calcium chloride, is CaCl2. So it's a metal containing compound, so 1 plus 2 species of Cl, 1 of Ca, so I value is 3. Kf is given to you. So if you can find molality, then we can find delta TF, right? What is molality? Moles over kilogram. We know 2.5 grams of CaCl2, which is in turn same as calcium molar mass is 40, plus 35 times 2 is 70. So roughly about 110 grams over 1 mole. And that'll give us 2.5 over 110. It's 0.0227 moles. And 150 grams of solvent is same as, you know what I'm doing, right? Kg is 0.150 kg. So molality is 0.0227 mole over 0.150 kg, which is 0.151 molality. So put it all in the picture. So that delta TF would be, Kf is 1.86, molality is 0.151, I value is 3, so it'll be 1.86 times 0.151 times 3, it's 0.84. Now this is the depression in freezing point. What is the actual freezing point? Means 0, that is TF equals 0 minus 0.84, which will be negative 0.84 degrees Celsius. So this is the elevation in freezing point. This is the freezing point itself. Okay. Now I forgot to include a problem for the one where I is 1 for the boiling point. So I put both those problems here. The top problem is freezing point where for a non-metallic compound. Similarly, a non-metallic compound boiling point problem is the second one. Practice both of these and include this in your mind thoughts. All right, I'll see you back with osmotic pressure and we will wrap up colligative properties.